In this video, I'm going to be talking about half-angle formulas. I do realize that we've already tested on this material, and technically on the final exam, I'm not checking your work. So if you can solve a problem like numbers 41 and 42 from the test review using a sum or difference formula or a double angle formula, then you do not have to use half angle formulas. But I'm going to explain it just in case, or for anybody who has not yet taken or retaken test 9. This will be very helpful. So the half angle formulas that we've given you are as follows. I cut off the tangent one because I would not recommend using the plus minus tangent formula. It's an unnecessary extra step, so I would recommend using either one of these first two. And really, when you're choosing between these two, they're equal in difficulty, so it really doesn't matter which one you choose. So a couple of things we need to know when we're looking at these half-angle formulas. The formulas are there to help you calculate the sine, cosine, or tangent for an angle. The angle that we're given is the half angle, and we use the full angle in the formula to help us calculate the value of that trig function. This is especially helpful when that half angle that we're given is not on our unit circle. I want to demonstrate this actually using an angle that is on our unit circle so that you can compare the answer that you already know with the formula, and maybe it helps you to visualize what exactly we're calculating. So the first one, find the sine of 45 degrees using half angle formulas. So because it is the sine, I'm going to be using this very first formula. Now the angle that is given inside the trig function, the one that we're evaluating, that is the half angle. So I like to write down just kind of a little note section off to the side that the half angle is 45 degrees. Now inside the formula, we are using the full angle. And again, the reasoning for that is you might know the full angle from your unit circle, so you can plug that information into the formula. If you already knew the values for that half angle, you wouldn't need the formula at all. You would just find the value from your unit circle. So we're assuming you don't know this value, but you do know the full angle from your unit circle. So in this case, we know both. That's just so that we can check our work. So the half angle is 45 degrees. If I multiply both sides of this formula by 2, that gives me that theta is 90 degrees. So this is the one I'm going to be using in the formula, and the point is to help me evaluate sine of 45 degrees as if I didn't know it from my unit circle. So using the formula, sine of 45 degrees equals plus or minus 1 minus cosine 90 degrees divided by 2. Okay, before we continue, we need to decide plus or minus, and we'll look at where 45 degrees is located around the unit circle. Now you can do this even if you don't know exactly the sine of 45 degrees, because you do know about your axes on the unit circle, and all we need to figure out is what quadrant it belongs in. So if you know your axes, then even if you didn't know 45 degrees exactly, we do know it is in quadrant 1, and all sine values in quadrant 1 are positive. So this is going to be a positive formula. So now I go on to simplify a little more. Positive 1 minus cosine of 90. We're assuming we know this one, but we don't know this one. Cosine of 90 would be 0. Now I'm going to simplify even more. And now I technically have an irrational denominator, so I'm going to split the numerator and denominator into two pieces. The numerator is equal to 1, and then the last step is to rationalize. Now that is what we were expecting, because we already know the sine of 45 degrees, but notice that we were able to use this formula to find it. So this is useful because sometimes we don't know that angle, and if we did know it, technically this is all extra work that you don't really need to do. So let's try this again with a different angle, this time one that's not on our unit circle. So again, you can kind of see that connection. So again, since it's asking us to use the half angle formula, I'm going to label this as theta over 2, because that is the half angle. Now to get full theta, I need to multiply both sides by 2. And that is an angle on my unit circle, so I should be able to tell anything about it that I need. Now I go back up to my formulas, and cosine is the second one. So I'm going to copy that down. Now remember, inside the formula, you're using theta. Outside the formula, you're using theta over 2. Right at the beginning, I like to decide on the plus minus. And since we are evaluating the cosine of 15 degrees, not the cosine of 30 degrees, I need to figure out where 15 degrees is located. I'm just checking for what quadrant so I can decide whether the cosine should be positive or negative. You'll notice that that is again in quadrant 1, and cosines in quadrant 1 are positive. Okay, so now I continue by just replacing and simplifying. 1 plus cosine of 30 degrees. And now this is the kind of problem that we saw a lot on test 9. You've got a radical inside of a radical. I don't expect you to completely rationalize this. What I do want is not to have two fractions. And basically you have a fraction in your numerator and it's being divided by something. So to get rid of that double fraction, I'm going to combine the two terms in the numerator into one fraction, then divide by 2. Now, a couple of errors that I want to point out that I saw a lot, just to kind of clarify those as we're working on this. First error that I saw a lot was that this 2 would suddenly leave the denominator. In your formula, that 2 is inside the radical. So the 2 needs to always stay inside the radical. It's still square root of 2 on the bottom. It is not being removed as just a whole number 2. That's not the same thing. So I need to make sure my radical is big enough to remind myself that 2 is still inside. I'm just cleaning up the numerator still. Now another error place that I saw, it all happened in I think the same step right here, 2 and root 3. Those cannot be combined together. They are not like terms, so the best that I can do is just set them next to each other with an addition symbol in between. There's no other way to simplify it. It would come out as a decimal. I cannot write it as 2 times root 3 because that's changing the operation that's happening. But my goal ultimately was to try and combine those into one denominator. So now I've got that 2 there. And this is still all over 2. All of that is still underneath the radical. Now here is another place where I saw a common error. When you go to divide by that 2, this is being divided by whole number 2, which means technically you could write it as 2 over 1. Now when you go to flip that fraction and multiply, it becomes 1 over 2, not 2. Dividing by 2 and multiplying by 2 are two different things. Dividing by 2 and multiplying by 1/2 are the same. So this is technically what we're doing. Now, if I go ahead and divide those, multiply across the bottom, I get 4. And now the last thing that I can possibly do to clean this up any further without getting too complicated is actually take that 4 out. Right now we've got the square root on top and a square root on bottom. Square root of 4 is 2. So I'm going to take that out. Notice that it is still in the denominator because that 4 is still in the denominator. All I've done is I've taken it out of the square root. So either one of these would be fine as an answer, but I do want to see it all combined into one fraction, not having two fractions right there in that answer. This is the cosine of 15 degrees. And of course it's a little ugly, so we didn't have you guys memorize it, but we were able to calculate it by using an angle that we do already know information about. So we did not have to use a graphing calculator to give us a decimal estimate. Now, when you're taking your final exam, you do have a graphing calculator with you, so you will be able to plug that in and get a decimal estimate. But be aware, because it is multiple choice, some answers may look like this, and you would need to know that this is the same thing as that decimal you're getting in your calculator. So what I would recommend is doing it by hand first, and then typing this into the calculator and see if you get the same answer as if you typed in cosine of 15. So I actually want to demonstrate that. It's a good self-check method, especially when you have a calculator in front of you. So I'm going to actually just live double check my answer, make sure I did everything correctly. Let's hope that I did. I'm going to type in everything that I have over here on my final answer. So I've got 1/2. Oops, hopefully you can see that. There we go. 1/2 root 2 plus root 3. And I close that double parentheses because the inside one is for the inside radical, the outside one is for the outside radical. So that's going to give me a decimal. Make sure I'm in degree mode. And the second thing I want to do is actually just punch in cosine of 15 because that's what I was trying to calculate. Now, if I did my calculations correctly on the paper, these should come out to be the exact same answer. And they are. So that has now confirmed to me that my work right here matched what it should have. And I did all of that algebra correctly. When you're doing your final exam, you have these calculators in front of you. So even if you don't know how to get here, you can check the answer choices A, B, C, D, type them in, and see which one comes up with the correct answer, cosine of 15. So that is a good way to do it when you have a multiple choice test. Of course, I would love for you to know how to do this algebraically. So what I would recommend is practice this. Type it in since you will have a graphing calculator and make sure that those come out to be the same. So now I have confirmed that the process that I used was all algebraically valid, and I have simplified as much as I can. All right, and then as usual, at the end of the video, if you have any further questions about these problems, you can always leave a comment and I will see it, or you can send me an email about this or any other problems that you would like to see worked out. Thank you.